This is Unit 3, Day 4. Okay, we're going to be talking about factor by grouping today. Example 23. Factor a binomial common factor out of each of the following expressions. Write your expression as the product of two binomials. Okay, so this is pretty easy. It's going to be the first time you see this, but basically you are always going to have a matching binomial. That matching binomial is, in this example, 2x plus 1. So that gets written once. Okay, so only write that once. And then what's on the outside gets written as another binomial together. So that would be represented as x plus 7. Again, it is two sets of binomials. Okay, moving on to part B. So x minus 2 is my match. That gets written once. And now what's on the outside gets written together. So my second binomial would be 5x minus 4. All right, C and D is a little bit harder because you have a bunch of little binomials there. So always find your match first. So my match is x minus 7. That gets written once. Now, this has to be combined. Okay, so you're going to combine like terms with those. So you really have, and then again, pay attention to the sign, that's a plus there. So you have x plus 5 plus an x plus 1. You combine like terms there, and that's going to be a 2x plus 6 is my second binomial. All right, D is just a little bit harder here. So my match is x plus 4. So that gets written first. But then, a little different, 2x plus 8 and the x minus 2, but notice there's a minus sign. So that really becomes negative x plus 2 that's combined. So now when I combine like terms with the 2x plus 8 and then negative x plus 2, my binomial is going to be x plus 10. Okay? All right, example 24. Write the expression x plus 3 times x minus 4, blah, 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 is the equivalent product of binomials. Test the equivalency with 2. Okay, so ready? Again, the matching binomial is going to be x plus 3. That gets written one time. And now the leftover is x minus 4 and this plus 5. So if you combine like terms right there, you're going to end up with x plus 1. Okay? So now what it wants you to do is you can use your calculator and just store. I want you to store the value as 2, or you could just do it all by hand. So when you plug in a 2 to each of these, you end up with 2 plus 3 times 2 minus 4 plus 5 times 2 plus 3. So if you kind of simplify your math, you're going to get 6 times negative 2 plus 5 times 5. Oops, that's not 6. That's a 5. It's 2 plus 3, which is 5. Okay, so you're going to get negative 10 plus 25. And negative 10 plus 25 is 15. So the original thing that they gave you is 15. Now, let's see what we have. Substitute in a 2. And you're going to get 2 plus 3 times 2 plus 1. So that's going to be 5 times 3, which is also 15. So this and this check out so we know what we did. You can also use the store key in your calculator. All right, this new type of factoring is known as factoring by grouping. This technique requires you to see structure in the expressions. Some very special polynomials can be formed by taking advantage of the structure we have seen in the last two examples. The key is to do mindful manipulations of expressions so that they remain equivalent but are written as an overall product. Example 25. Consider the expression, you can read that, justify each step below, using commutative, associative, or distributive. All right, well, looking at this first step, basically you have this expression, and then all of a sudden they regrouped using parentheses, so it's just the associative property. Okay, now what happens is you're kind of factoring out something, so that's the distributive property. All right, and now all they did was factor out the match and then put your leftovers, so it's going to be distributive again. All right, moving on. So when we factor by grouping, we first extract common factors from pairs of binomials in the four-term binomial. So one thing you have to know is you're always going to factor by grouping if there's four terms. Okay, so what we started with in example 23 is a little unrealistic. This is what you guys would see on a test or on your quiz. So there's four terms, okay? So we do have to completely factor. So that means there might be 2 steps to be done with this. You're not going to be one and done. You have to make sure everything's simplified. All right, so what you're going to do is you're going to split your middle, and then you're going to run 2 GCFs. So you're going to GCF the first 2 terms, and then you're going to GCF the second 2 terms. And if you do this correctly, you're going to get a set of matching binomials that are in the parentheses. So in the first example, I'm going to factor out an x squared. So when I factor out an x squared, I'm left with 3x plus 2. Okay, and the second one, now my goal is to have a 3x plus 2 in parentheses over on this side. So I can't take out a 9, I have to take out a negative 9. So now when I divide both these terms by negative 9, negative 27x divided by negative 9 would be a positive 3x. If you accidentally thought it was just a 9, you end up with negative 3x, and then you would realize that these parentheses wouldn't match. Okay, so then I divide my negative 18 by negative 9, and I get positive 2. So you write your match down once. So I have 3x plus 2 as my matching binomial. And now, like we talked about before, this is what's outside. That gets written together. So that's going to be the binomial x squared minus 9. But because the directions said factor completely, you should be able to recognize that this is a difference of a perfect square. So to clean that up, I carry over to the 3x plus 2, but now the difference of the perfect square, if I factor that, I'm left with x plus 3 times x minus 3. Question B. So split down the middle. I'm going to factor out a 9x squared. If I factor out a 9x squared, I'm left with 2x plus 1. Again, my goal is to get that matching 2x plus 1 on the other side. So these, you might say, well, these have nothing in common. So the only thing I could take out is a negative 1. Now, if you thought 1, fine, but then you're going to get opposite signs in the parentheses. So if you divide out a negative 1, you're going to be left with a matching 2x plus 1. The matching binomial gets written once, so you're going to get 2x plus 1. And then my outsides are 9x squared minus 1. Okay? Now, hopefully you can recognize that this is a difference of a perfect square. And don't forget the criteria for a difference of a perfect square. It has to be a binomial, so it has 2 terms. It has to be subtraction. And then everything has to be perfect in here. So the numbers have to be perfect squares, but the variables are always even powers in order for them to be perfect. So I copy down the 2x plus 1, and now the DPS of that is going to be 3x plus 1 and 3x minus 1. Okay? Moving on. GCF the left side here. I could take out an x cubed. When I take out an x cubed, I'm left with x squared plus 4. Okay? Factor out a 2, I'm left with x squared plus 4. So my matching binomial gets written once as x squared plus 4, and my outsides get written as x cubed plus 2. Be careful. This is not a difference of a perfect square because that's a plus, that's an addition, and it needs to be minus. So that one's done. Last part here, part D. I could factor out a 5x squared. When I factor out a 5x squared, I'm left with x plus 2. Okay, on the right side, I can factor a 20 out from both of them. I'm left with x plus 2. So that matching binomial, x plus 2, gets written once. My outside is 5x squared plus 20. Now, hopefully, you can recognize that there's a GCF left in this one. Okay, so if I GCF that, I'm going to factor out a 5, and I'm left with x squared plus 4. And then I have to carry along my x plus 2, which was my first binomial. Again, recognize that this is positive, so it's not a difference of a perfect square. Okay, example 27. Consider the expression x squared plus ab minus ax minus bx. How can you rewrite the expression so that the first two terms share a common factor other than 1? What property is being used? Okay. So basically, if I were to split this down the middle, you might say that there's nothing you can factor out. So it just wants you to rearrange it. So technically, I can just switch. If I switch those two spots, I can rewrite x squared minus ax plus ab minus bx. So the only thing I did was switch the position of those two, because now if I were to split down the middle, I have a GCF pulling out of x, okay? And over here I have a GCF pulling out of b. Okay, what property is that? That's the commutative. Okay, anytime you just kind of switch the order or flip the order, that's commutative. All right, write the expression as the equivalent product of binomials. All right, so you're going to factor this here. I'll kind of continue up here. So I'm going to divide out an x. If I divide out an x, I'm left with x minus a. So my goal is to get that matching binomial of x minus a. So factor out a b. You divide both by b, you're left with a minus x. Oops, I'm sorry. You have to factor out. Do you guys see what happened? If I thought it was b, you'd end up with this, but then look, the signs are opposite. That's positive a, that's negative a. So that's telling me I have to pull out a negative b to get the signs I want. When I pull out a negative b, then I'm left with a negative a plus x, which is the commutative same property there. So my matching binomial, okay, just make sure you pick, I usually put the x first. Those are really the same. So that's x minus a is one binomial, and then my outsides here are x minus b. So as you can see, as I was doing that, I thought I was only taking out a b, but then the signs didn't work out in parentheses, so you have to pull out the negative. Example 28. Consider the expression, and it's stated there. Explain the error made in factoring. How can you tell the factoring was incorrect? All right, so here's what they originally gave you, and then look what happened, guys. Those weren't matching. Those have to be matching. So there was no matching binomial. If you're factoring by grouping, there has to be that matching binomial, okay? You can refoil, and then it says, how can you tell that the factoring is incorrect? Well, if you refoil it, or just foil, I don't know why I'm saying refoil, you can foil to check the answer, and you would have to end up back up at the top, and it's not going to work. Or you can use your store key in the calculator. Store your favorite value, put in the original up here, set it equal to what you think the answer is, and it would tell you true or false. So you would look for true or false. So if it says true, then you know you did it right. If it said false, then you know you did something wrong. Example 29. Factor by the AC method, which is also called split the method. All right, so now what happens is you now have guess and check. So that's by like trial and error. I taught you guys slip and slide. And now you have this AC split the middle. So you basically have three different ways that you can factor these quadratics when you have a leading coefficient greater than 1. Okay, so how do I know it? Look, there's a leading coefficient there, and there's no GCF to factor out. Okay, so now it says factor. So I would probably sit there and do a slip and slide, or I can sit there and just do guess and check. But what's going to happen is you're going to get that it is 2x plus 3 times 3x minus 2. Okay, so if you were to factor that. Why is the guess and check method so time consuming? Well, it's because there's so many possible guesses. Okay, so it takes forever. So that's why I have showed you slip and slide, but now I'm going to teach you AC method. Okay, so it says in the next couple examples, we will explore another way to factor trinomial quadratic expressions with a leading coefficient that's not 1. So guys, you know that you're going to be doing this slip and slide or AC split the middle when the leading coefficient is greater than 1 and nothing can be factored out. Okay, I'm actually going to stop right here because it looks like the time on the video is going to run out, so I'll continue in part 2.